Hi, Bobby. How are you? Sleeper.
All right, let's start the meeting. Hi, everyone. I'm Bobby. Um, we are going to start this meeting by going over quite a few agenda items. The first thing that I would like to talk about is to give a quick update on 1.10 items that we wanted to release. And unfortunately, most of them, I guess, didn't make it to 110 for various reasons. The first item that I would like to talk about is priority and preemption. We decided to not move it to beta in 110, particularly because we didn't find enough customers to try it. Second item was the fact that we saw some scalability tests failing, and we would like to address the scalability issues in priority and preemption. Third thing is the fact that we don't have proper support yet in daemon set controller to create pods and let the default scheduler schedule them. Basically, we needed this feature in order to have priority and preemption for daemon set pods. As you can imagine, one of the most important use cases for preemption is to ensure that critical pods, which are mostly like daemon set pods, can be scheduled in a cluster. And we didn't want to go to beta without having this feature for our critical pods. These are some of the reasons we decided not to go to beta in 110. The second item was equivalence cache. By the way, all of these items are in that spreadsheet that is sent to the mailing list. You may want to take a look at this spreadsheet. The second item is equivalence cache to beta. Equivalence cache is the cache that lets us cache predicate results for pods which are equivalent. We wanted to move it to beta, but as a part of moving to beta, we wanted to have better hashing for equivalent pods. Jonathan, whose GitHub ID is Mr. Kid, was working on this, but after changing the algorithm for calculating hash for these pods, we realized that we saw some throughput drop, scheduler throughput drop. We wanted to address this. Harry looked at it, but I guess he was also busy. He didn't finish the work on time for 110. And Jonathan himself is on paternity leave, so he wasn't working on this. So this one has slipped as well. There was another item on the on our list, which was to support maximum of n pods per topology for affinity and anti-affinity. After much discussions, we decided to, at least for now, put this item on hold because we already see some issues in scalability of affinity and anti-affinity, and we see lots of slowdown if you especially enable anti-affinity in a cluster and have some pods in a cluster that has anti-affinity. We would like to address the performance issues before adding any more features. And in fact, we are not so sure if this particular feature, basically having like a maximum of n pods per topology for affinity and anti-affinity, has much use. We don't know. We don't have any compelling use cases at this point, basically. Tim, do you have any questions, suggestions? Maybe not.
Not right now. I mean, I'd have to. It's been a long-standing item. To be honest, there's parts of the design there that are suboptimal, a bunch of them, and I don't know how you get around it without re-architecting pieces. It requires a fundamental rethought or rethink how you would even do it. That's kind of where some of the aspects of Firmament come in, but I don't think that's anywhere ready for, prime time as the default, which will lead into other topics, I think, because we need to talk about that today. But I don't see how you get around it with the way it's currently being done. You could refactor it in some ways, but I would never do any topology key other than hosts right now.
Yes, that's right. So we actually, in order to make affinity and anti-affinity more practical, I think we need to limit parts of its design in a way. So we need to probably limit it or restrict the topology key to certain values, and probably like host is going to be the most useful and I would say easiest thing to fix. When it goes to a larger scope, then performance is going to degrade to an extent. So we may never be able to run this for a very large cluster. But if we come up with a much better mechanism or some sort of, I don't know, dynamic programming that can cache certain things, we may really achieve better performance. But I don't have any great ideas at this point.
Well, one of the things I was thinking about for a long time was to have right now the cache is a linear sort of caching mechanism, and it doesn't necessarily store it in a data structure which allows for login access or less than that. Because if you were to, have, a red-black tree stored on labels, you might be able to do faster lookups, and it would be much more effective for doing matching, right? But that means like having like an index over your cache, right? You would have like that two-tier process would allow you to do this. And that was one of the ways we talked about this a long time ago as one of the possible ways to optimize for getting around this problem.
But the challenge here is that we have to do matching for the labels, right? And
Yes.
And in fact, each term of affinity and anti-affinity can have a particular label selector. So I don't think that reorganizing the pods in like a red-black tree, is that what you're suggesting?
I'm suggesting not organizing the pods themselves, but organizing like an index. So you would have an index where the key would be the label, right? And then it would eventually point to the pod itself inside of there. So basically like very similar to how databases create indices. So you can create an index on multiple different tables, and it would basically be a set of pointers or a way of setting up fast access to get to the individual data elements behind it. So that would just be an index optimized for accessing the labels.
I see. Yeah, this is an idea worth exploring. There are still some unknowns in this topic because label selectors can be complex. They are not necessarily matching the exact same label. They can match other things as well. They can be like not match a label. They can be like the label is in this like array or list and stuff like that, which makes it harder.
Yeah, it does. But there's the fundamental problem is that in order to get at the labels, you need to iterate over every pod in order for you to see it, and then transact on that versus actually having an indexed walkthrough or a map of some kind to be able to access to figure out from a label what are the pods, right?
Right, so. Absolutely. I totally understand. And in fact, we actually built some metadata, as we call it, like predicate metadata that has some of this information for pods that match certain terms, but they are not necessarily enough. And we definitely should explore some of these ideas more. Hopefully we can improve performance of affinity and anti-affinity to a much better levels. So there is another item, design doc for policy library of a scheduler, so other can reuse them. So I guess Klaus has put this in a document. I guess his idea was to make portions of scheduler convert some of it into a library so that other components can use these libraries and functions easier in other pieces of the code. I believe we already have some of that. I don't know if Klaus himself is here to explain his ideas a little better, but I don't think so.
He's in China, so he's probably asleep right now.
Yeah. So, but anyways, he has also put this item in our 1.11 list. So he will probably explain it a little bit more. He had sent an email as well, but I would like to hear himself telling us a little bit more about what he has in mind. And then there was taints and tolerations to GA, which was done, which is done already. Actually, it was not much of work. We had to only update the documents. We had some discussion actually about some other usages of taints and toleration, which are not gonna go to GA anytime soon, I guess. For example, some of them are already in beta. They're still in alpha, not even in beta. So those are gonna take some time before we can move them to GA. One of them, which is probably very useful for ourselves and many others, is a tainting node by condition. So basically, when a node is not ready, we can taint a node properly, maybe with no schedule, for example, or other taints that we can add. And when the node becomes ready, for example, we remove this taint. And some pods can have the toleration. This is particularly useful for us, for example, when we want to schedule daemon set pods, because those pods are usually resilient against no scheduled bit or unschedulable bit of nodes, for example, that we have today. If we remove those bits and work with taints only, we can easily have the daemon set controller to add the toleration, proper toleration for the pods that it creates, and everything will work as expected, and we won't need any changes to the scheduler code itself, and we want to schedule daemon set pods. So we would like to move this item to beta in the next release 1.11. Hopefully we can move this to beta there. And let's look at the other items. Of course, bunch of these items that is slipped in 1.10, we still would like to do in 1.11. Priority and preemption to beta, we would like to do it in 1.11. Equivalence cache to beta, again, we would like to do it in 1.11. Klaus wants to do the library in 1.11. He would like to add gang scheduling support in 1.11. We should discuss this a little bit more. I don't have a very clear understanding, or haven't seen any, I guess, like a detailed design about how this should be done, or what kind of API changes we need to do. But anyway, hopefully we get more information about this feature before going to in 1.11. And as I said, we would like to graduate taint nodes by condition, and also removal of the scheduling logic of daemon set controller in 1.11. These are the items that we had for 1.11, but if you have more items, please comment on that under the spreadsheet so that we can add them to the list. There were a couple other emails that we received. One was by Klaus. I guess we talked about those we covered them all.
One thing, like
yeah, go ahead.
Two things related to priority preemption. So like two features. I think you are already aware, like resource quota and priority class whitelist per namespace.
Yeah. So I guess that's the next item basically on the agenda. So so resource quota for priority class is something that is moving forward, and I think all agreed on the design. So implementation is actually, I guess.
Vikas has already a PR, and some people have reviewed also. So I think that is moving forward. But I think it's still like I would like to discuss that whitelist of priority classes per namespace. How we would like to go about it. Because I think Ravi was telling he had some offline discussion with you. And I think he said that you are more interested to have that in resource quota admission plugin. uh, uh, also like uh, I'm not saying that might not be I mean that might be a bad idea or something, but I think what I think from my point of view, like resource quota should be consider should worry about just resource quota. It should not worry about what priority class a pod can be assigned, right?
Okay.
So
But
so
the
so,
resource
so
quota can be used to limit the priority classes that can be created in a particular namespace, right? I mean, you can, for
I
example,
mean,
use your zero
no,
quota at a particular priority, or you can do default deny in a particular namespace and give a quota only for a couple of priority classes, for example, to the users.
yeah. I mean, giving resource quota to I think priority classes is one thing, but to have to like what priority classes are allowed in a namespace, I'm not sure that that should be part of the resource quota admission plugin. I mean,
My only I hear what you're saying, but my only concern is that this is something that can be achieved easily with
uh,
resource quota, basically. So let's say that you want to whitelist only 2 priority classes in a namespace, right?
yeah.
But I guess by saying you want to whitelist, it means that you cannot create any other priority classes in that particular namespace. Is that right?
Uh, I mean, I wouldn't say you cannot create. I don't know where you say create, but yeah, no pod can be assigned to any other priority class.
Right.
Yeah, in that
So basically,
namespace.
yes. So in that case, I guess you could say, for example, default is denied for that namespace if a user does not have any, or if there is no quota for that namespace, then users cannot create any pods, and then you only create quota at particular priority classes. For example, those 2 priority classes that you want to whitelist, you just create infinite quota for them in that particular space, and then you can achieve what you wanted to achieve with whitelisting those 2 priority
I think you're kind of hijacking. I think what Uvesh is saying is you're hijacking resource quota to achieve a
Uh,
goal, and I think it's
yeah,
from a UX perspective. I can see how that could be confusing
yeah.
for an
That
operator.
my
I
concern
But
feel like
also.
having like
but
two parallel sort of like 2 parallel features that do the same thing is kind of more confusing. But
No, actually,
no, I don't disagree. I think, but I also think that whitelisting for a given namespace almost lives at the admission control level for like a webhook. It's a policy constraint, right?
yes.
so is
Um, well, yeah, but it's not resource quota is a bound scope thing. Is it like it defines resource quota? If you want to whitelist, I mean, this was the argument I originally made. If you want to whitelist, is why don't you just write your own webhook admission controller? That would totally allow you to define any policy you wanted, including white spacing certain priority classes to certain namespaces.
right. Are you suggesting? But what that still requires some sort of I don't know, either API changes or annotations or something to
You,
specify the whitelist, right?
you would have to define the spec for how you want it to handle it, but that basically doesn't. It says we don't. It says Kubernetes proper is punting on the idea and saying like you define policy because this is a policy question. So according to Brian's picture diagram, which I'll try to see if I can grab over here, right? Oh no, I'm going to take everything else down. If you define policy, you're way up the stack. You're not in Kubernetes proper anymore. So let's see here. You're in governance, right? You're in the governance layer of the stack, right? So if you're in the governance layer of the stack, we provide the tooling to allow you to do the governance, but we don't enforce policy. That's up to you to decide, right? Because there's many ways to slice it. And if you conflate resource quota to do this, resource quota becomes confusing. It's already confusing, right? It totally is. But if you conflate it, it gets even more confusing. Now, if you were to say like we're gonna also whitelist with that, then it becomes even more confusing. You could do it. There's many ways to hijack the system. But what I'm saying is that if you want to apply policy, why don't we strictly adhere to the layer diagram and say like policy we're going to punt that idea off to whoever wants to implement that policy. And
so from the very beginning that we designed this, I'm not saying that this is a good reason necessarily, but from the very beginning that we designed the priority class, we had this idea that in order to limit someone from creating pods, for example, or a certain amount of resources, or using certain amount of resources at a particular priority, we are going to introduce resource quota, and we are going to add priority classes to resource quota. So for example, you can say at this particular priority, user X does not have any quota, or at this particular other priority, the user has 2 gigabytes of RAM and no more than that. So that was the intention from the beginning, and that's maybe why I always think that resource quota is the main mechanism to allow or disallow creating pods at a particular priority in any namespace.
I'm not opposed to it. I just think it's confusing.
Okay.
So actually, pod is a resource. So if resource quota is controlling that, I think that makes sense. I mean, like for example, at least in the design document, I have seen there are some examples, 2 examples, where like how many pods can be created in a particular priority class. Because pod is also a resource. So whether a pod can be created or not, because also like it's like it can be either 1 or 0. It's not like other quantity like CPU or memory. So but pod is a resource like others like CPU and memory. So that's why like it's perfectly applicable to pods, and controlling pods in resource code, that makes sense.
So yes, it does, and that's why I also think that the resource quota is good enough for allowing or disallowing creation of pods in a particular namespace. So I guess you are suggesting that we should create another mechanism for creating, or limiting, or allowing.
No. Limiting pods in a particular priority class, definitely like the way it's being done in resource quota should happen there. Only thing like what a priority class a pod should be assigned or not could happen in another like we already have priority admission plugin. It could happen there. That would be, I think, a better place. I mean, I'm not saying to create another new admission plugin, but we already have priority admission plugin, right? I think that would be a better place for that. That's what I'm saying. And it would be.
How do you? Okay, so it really depends on how we implement this in our API. I guess the initial suggestion was to add annotations, which was not a good idea in my opinion.
Actually, annotation. Yeah, actually, you might think annotation might not be good idea. But like historically, like some features initially that were not supposed to be, or initially the way new features were started, they were started based on annotations. So maybe that might be the historical reason, like why we did annotation based. Like for example, we have been doing similar thing in pod node selector plugin and pod tolerance restriction plugins. We are doing the same thing. So that's why, like, I think what I'm saying, starting with annotations to have whitelisting I mean, wouldn't be a bad idea, because that's what we have been doing for pod node selector plugin, admission plugin, and pod tolerance restrictions, and we have been using them in our production clusters, and moving them from annotations to namespace fields. I'm not sure like whether like we would want to go that path or not.
So it's actually, of course, annotations and fields and all are all attached to an object, and you can use them in any ways you like.
Yeah.
Especially annotations and labels or something that are very, very generic, and people could possibly, in a way, abuse the flexibility there.
Yeah.
We have done that in our Kubernetes code sometimes. But recently, I was using annotations, for example, for preemption, and Brian told me that annotations are not meant to communicate anything among components, or they are not meant to configure any cluster or set any policies anywhere. So I guess for these reasons, we should avoid creating more exceptions to using annotations for configuring clusters. That's basically my concern. We should probably have consistent APIs. If you would like to add, I don't know, another API to give whitelisting of priorities per namespace, we should do it properly.
If you think like people from, I don't know, API machinery, like would be okay adding new fields in namespace object for whitelisting namespaces. I am okay with that, but I'm not sure like initially whether they would want to go with that or not.
If our reasoning is strong enough for namespace whitelisting, they should
Yeah.
possibly accept, right?
Yeah. As I said, for like pod node selector plugins and these, like, because these, like, we have been using in multi-tenant environments, so definitely like they are useful. Yeah. So valid reasoning is there, but I don't know whether it's because using annotation, it's really easier to start to have that feature in place than
Yeah.
to go and add new field in the namespace object, because that is such a
It's always
fundamental object.
to start, and once we start it, people are not going to change them. That's the hard part. So changing them to proper things is the hard part, and as a result, a lot of things just keep getting accumulated and never fixed. That's a concern that I have.
Yeah, so maybe like okay, in fact, that's the idea. That's better. In fact, even I prefer that. So maybe I think Ravi is planning to work on that. Definitely, like he can start with priority admission plugin, and he can have this feature implemented, and he can add new fields to namespace object, and he can definitely try, and let's see like what feedback we get. Yeah.
Okay. All right. So.
And another thing, I think Ravi has one more thing.
Yes, Ravi has another
yeah.
item. Right.
Yeah.
Ravi, are you there? Do you want to start?
Yes, I am.
Hi, Ravi. Okay, go ahead.
Okay. So let me know once you are able to see the screen.
I can.
Okay. So this is the basic architecture that we are planning to use. We have a Kubernetes scheduler. Okay. Before that, I just want to give some background. Like last week, we have discussed on the usage-based scheduling, and we have decided to use the scheduler extender to implement that. So this is the architecture of how we want to use scheduler or usage-based scheduling. So the Kubernetes scheduler talks to the extender, and the extender queries the information store. The information store could be like having historical information or the current usage information of nodes or pods, whatever it is. In this case, we are going to use only the nodes. So as of now, we are using metric server to get the information related to nodes, and the metric server stores the data for a 1 minute window for all the nodes. We're going to query that and then get the usage for every node, based on which we are going to send that response back to the scheduler saying these are the list of nodes out of which this is the node that has got the least utilization. That is the idea that we are using here. So I have implemented a basic extender. So let me try to minimize this. Okay.
So basically, you're using the prioritize verb for this, right?
As of now, I'm using the filter verb.
Okay.
But I can change it to prioritize as well.
So, but basically, I'm wondering, when you filter, how do you pass information about like score of the nodes and all? But back to the scheduler, basically, from the extender to the scheduler.
So in a filter, I don't think we'll be passing score.
Okay. Yeah.
We
so that's
just pass the nodes.
Right. So how do you filter out nodes? Basically, this scheduler based on usage seems to me like a priority function, not necessarily a predicate, right?
Yeah. I agree. I think I think we can change that. Yeah.
Right, yeah. So I have set up a 3-node cluster here, and each node has got like one core, and we are going to use CPU as the metric based on which we make the decisions. So in here we have the extender, which is like a HTTP server already running, and we have passed the kube config to that so that we can talk to the corresponding cluster. And this also uses the metrics client, which is available in the metrics server. The same thing is being used by the horizontal pod autoscaler. So as of now, we have like 2 nodes in the cluster. So I have given the UUIDs for the nodes. So this is the first node and this is the second node. And so the metrics, if we query them from the metrics server, they're going to look something like this. The current usage for one of the nodes, which is this node, 93598, is 23 millicores, like 93598 is 23 millicores. But as per the request, what we have seen here is 270 millicores. And for the other node, it will be more or less same. For the other node, it's around like 530 millicores, the CPU usage, which is this node, 9A2D, and it is around like 41 millicores. But what we are seeing here is around 53 millicores. So I'm going to create a pod now, which actually lands onto the node which has got least CPU utilization, which should be this. Hopefully it works. Okay. So one node has got like 41 as the CPU utilization. 41 is the 41 millicores that we are using, and the other node has got like 24, which is this value. So we have chosen the other node, which is around like 24, because that is the least CPU utilized node. And if we look at the pod template, it is like it's just a pod which runs infinitely and then does an echo. We want to make sure that once the pod lands onto this node, it actually crosses the CPU, the utilization on this on the other node. Like it's going to cross the 41 millicores. Now let's look at the usage of the nodes. Sorry. So it's going to take some time because the collection duration is around like 1 minute.
Oh, that was actually my question. I was wondering how frequently these metric servers are updated. So it looks like it's 1 minute, huh?
Yeah. So this is the window. So it's going to collect in the past 1 minute. What is the utilization on the node?
So and then what is the update mechanism? Is it like polling nodes or nodes push information to the metric server?
I'm not 100% sure about how that internally works.
Okay.
So we see this, the other node is like around 830 millicores now. The actual usage, like previously it was around like 24. That was the node that we have chosen, like 93598. Now its usage is around like 830 millicores. Now if we go back and look at the usage that CPU sees, because we look at only the So like as of now, the scheduler can see only 270 millicores as the usage because that's the total requests available. But in fact, this is using like 830 millicores. Now, if I create some other, like I'm going to create a new deployment with the name Nginx. So we're going to choose the other node, which is previously it was around like 41 millicores. And we are going to choose that node because this node is like it's around like almost 830 millicores is being used there. And if we don't use the extender, the scheduler would have actually landed those pods onto the same node which is having 830 millicores. Because we are using this usage-based mechanism, we are landing onto the other node where the usage is actually less.
Right. So let me see the output. So it says the node, you schedule something with minimum. Okay. So, but there were like 4 instances of this or this deployment, right?
Right. So if you see this, this has got like all the four replicas basically.
Yeah.
So everything has gone to this.
I see. So since all of the 4s were created at the same time, I guess so the usage base was not updated at that point, I guess. So,
right, because it's talking to metric server, and metric server just responded back saying that as of now it is 40.
Yeah. Makes sense. Although I guess that 1 minute is a little too long for a scheduler or a realistic system to actually act upon. So maybe if we really want to use it, we should probably make more frequent usage updates. I don't know how frequent we can go, but
so I was checking the documentation and they told that this 1 minute has been chosen like kind of randomly, and based on the requirements, the window could be either increased or decreased.
I see. Okay. Yeah, that sounds interesting. Although one problem that almost always exists is the fact that once someone creates a collection, like a deployment or replicas or whatever, there is going to be like a burst of pods that are created at the same time. And I guess this usage-based scheduling won't be super useful for scheduling multiple instances of the same collection. But this is nevertheless useful for a little bit, if you consider a little longer periods of scheduling, this is going to be useful for pods that are created with enough time distance from one another.
Yeah.
Right. The other thing is, as of now, we don't have an official like tool which stores the information for a long period of time, based on which we can make some intelligent decisions at least.
Right.
Whatever Tim was suggesting last time. So I was talking to the people who are involved in instrumentation. They told if there is a strong requirement for it, they would get started on working on it.
Okay, sounds good. All right, thank you very much, Ravi.
Yeah, stop sharing. Thank you.
All right.
Yeah. That's
if anybody has any questions about Ravi's demo, please go ahead. All right.
I was also wondering one thing, like as a next step for this usage-based scheduling, do you have any feedback or anything? Like one thing I was wondering, like right now whatever code Ravi has, he has in his own repo. Like in the future, when when his repo is in a better shape, because now we can have for our SIG scheduling our own repo, right? Under that we can have projects. I don't know whether we want to. It would be helpful to move it there to have more feedback.
Yeah, I think it'll be useful actually. I think this is one of the features that we would like to add to the scheduler. At least I would like to see in the scheduler, because it's going to be useful. Today we don't have any idea of the usage, and at the same time we have a bunch of pods that don't specify limits, so they could be using a lot more than what they request. And we see, when we assign those to nodes sometimes have to delete other pods, or the pods just assign themselves. So it's going to cause a little bit of a unnecessary churn in the cluster. So in order to avoid that, it would be useful to have a usage-based scheduling. The only problem here is that that 1 minute that we just
Yeah,
talked about is a little too
right,
long,
right.
but otherwise this could be useful.
Yeah, I mean, still, yeah, obviously there are some issues that needs to be addressed. Yeah, definitely.
Yeah, of course. This is a very
That's why I think Ravi started as an extender, because it's at least using extender, it's easier to test. Yeah,
absolutely yes. We also need to think about performance implications of going to
exactly. Yeah, yeah.
a third component and getting the usage information and all. But anyways, once we address these, this can be a useful feature.
This kind of lends itself into like a segue into some of the other issues we were having with regards to there's broader topics and conversations that we need to discuss. I didn't put it on the agenda, but I'm going to hijack this as a reason to do it. One of which was in order for us to get repos, like one of the things we're talking about in the steering committee, in order for us to get repos, we need to update the charter and their charter template, which is still in flux. And that would allow us to incubate the repositories. And I don't think that'll be hard for us because we're pretty well defined and scope bounded. So I think we can easily update that once the PR has been merged for the charter. I think there was some broader questions that I don't know if Deepak wanted to go into with regards to ownership of some of the repositories that we talked about last time.
Oh, about the firmament thing?
Yeah.
Oh, okay. Yeah, so essentially you saw that email which I sent it to you last night, actually. So we, based on the discussion with Malti and so this is what we decided. So we're going to keep the Poseidon repo as part of the incubation. So they're going to transfer over. Did you get a notification from Malti yet?
I got an email. I did not get a separate notification on the Kubernetes SIG org thing.
Okay, because I guess this is how it works. So because once he does the transfer, then you get a notification and you have to accept it.
Yes.
So that was one thing, and then the other thing was the firmament repo is going to stay where it is right now. It's in Kansas, actually, because the reason being is firmament scheduler can run on top of Kubernetes, Mesos, and Swarm, and other cluster managers as well. So that's what. So there will be dependency from our perspective, from Poseidon perspective. So currently, actually, firmament does not really have a release process. So we're going to build a release process as well. So for example, we are actually currently we are making a lot of changes to firmament. We are adding all this affinity, and currently we're working on the node level affinity thing, and then we're going to start working on the pod level affinity. So as we start making these changes to firmament, so we're going to have different versions of firmament. So we need to kind of coordinate that as part of the release cycle for our incubation project as well. So that's the plan. So essentially, we'll have dependency releases in firmament, and then we'll have releases in our incubation project. And the packaging, the deployment packaging using charts or whatever, we'll control that basically.
Okay, by the way, what do you exactly mean by a separate version for example, an additional feature? Is it like the progressing?
Yeah, exactly.
Okay.
Yeah. So for example, we have one version of Poseidon, and then we added affinity, but the Poseidon is not ready yet, for example. So we will have a packaging so that it points to the previous version of firmament.
Sure.
Yeah,
sure.
Exactly. Because this is the problem with the integration thing. It's kind of moving target. So we need to kind of very tightly control that.
Yeah, sure. That's fine. I somehow got the impression that maybe you are creating like a completely separate two versions, that one may support affinity and the other one.
No. That's what we wanted to avoid in the first place. That's the reason we are letting it stay there in Kansas, because they're going to be other contributors outside of Kubernetes also. They may want to add some features, which possibly we can leverage as well, though, I see. So by having a one centralized place, and then,
Yeah, makes sense. Okay. All right. And Is there anything else anybody wants to talk about? We have another 12 minutes left.
I just wanted to add a comment. I think you mentioned that Klaus mentioned that you folks are going to start. I guess maybe he's going to start looking at the policy base, the scheduling policy thing. So there's an initiative going on called OPA. So I think you might be familiar. So they're trying to see if OPA framework can be used across the board for all kind of policy needs, the networking policies. So I'm possibly thinking maybe it can be leveraged for scheduling policies as well.
Yeah, I don't have enough information about it. Actually, if this is something that we can leverage, absolutely, we will look into it. And we are changing. By we are changing, we plan to change scheduler to a more like extensible, configurable platform. Mm-hmm. And we would definitely look into other better possibilities for like extensions and using better architectures for policy based scheduling. I'll take a look actually at that.
Yeah, so I can send out because I have a lot of information. Actually, we started work. I think you guys are very closely, Google guys are very closely working with the company called Styra.
Mm-hmm. So there are so many things going on around.
Yeah, I think so. CNCF Google was the sponsor for that project actually.
I see. Okay. Yeah, please send me the information. I will take it.
Sure.
All right. And I would like to add one thing. Given that we had a bunch of things on our plate, they were a little ambitious, I would say, but we didn't make many of them to basically we couldn't prepare many of them for the release. So if you guys agree, starting next scheduling meeting, we are going to go over our list of agenda items for 1.11 release and have a quick update on the status of each one of them so that we can better track them and hopefully we can raise our productivity a little bit more. Okay. Is there anything else? Anybody?
So Tim, are we good to go then? Do you need anything from us or?
I just need to know when I have not gotten an email of the transfer and when the transfer.
Oh, you haven't yet. Okay. I'll ping him again. Yeah. Okay.
So whenever that comes through, I can just.
I'll send you the list of the reviewers and all that. Just by the way, once you get it, so you can. I think it's the same information with Shiva. I think he's on the call as well.
Yeah, I saw that original email.
It's the same thing. So now we don't need to worry about firmament. So you can just use the same email, but just do that for Poseidon.
Okay.
Okay, great. I'll ping Malti again. Yeah.
All right. Anything else? All right. Thanks, everyone. We will get together again in 2 weeks. Bye.
Okay. Thanks. Bye-bye.
Thank you.
Thank you.